So thank you very much for the big expectations. Now, now I need to follow through. So actually, GraphQL London is a really good meetup. It recently had some really good videos and lectures and talks on this topic. So if you like what you see here, then just go to Gerard, tell him like where can I get this awesome videos, which is probably YouTube or something, right?
Yeah, these are on YouTube.
Yeah. So, yeah. So my talk will be about GraphQL subscriptions. I'm David, and I want to give you a full disclosure about this slide deck. It contains a lot of animations. Some of them are really small, and some of them are pretty insane. But but just don't get too distracted by these animations because it's just like there is real content inside of this deck. So I'm a freelance developer. I also work with a group of freelancers called the Guild. We develop products for many big organizations like banks, hospitals, and universities. At the Guild, we strive to contribute to open source projects that we use daily in our work. For instance, I contribute to the Apollo project, which is the most mature GraphQL framework at the moment for JavaScript. And we also lead local and global communities in order to get the open source projects more like a better community, more attention. And so, for example, I organized the GraphQL Tel Aviv meetup, which is where I'm from. And this group currently has 300 developers. We are all very excited about GraphQL, and this is very like every person that will talk to you about GraphQL will be very excited about it. So just keep that in mind. So the agenda for today would be to walk you through the GraphQL basics. Then we'll take a look at the subscription spec and what it allows us until now. Then we will briefly go through some code examples from Apollo. And lastly, we'd go over some more advanced implementations. So what is GraphQL? Well, GraphQL really is an API query language. It allows you to define your API with its strongly typed schema language. Then, on any client, you can write query documents that will be sent to your API server. And it, in return, will send you the result at the exact same shape as your queries. Every field in your query is defined by either a complex or primitive type. That allows us to easily validate data returned, so the client will get exactly what it expects. It also allows us to create smart developer tools that knows what our applications has to offer. For example, the most familiar tool that actually ships with every GraphQL framework is this Graphical app, which is really a simple query execution app. But using the GraphQL schema, it has auto-completion and documentation out of the box. And it really allows us to explore an API in a matter of minutes. So I've explained to you what the language or the query language is in GraphQL, but it does contain graph in it, so where is this graph? Well, because of the way GraphQL works, it requires us to define our whole application domain as a graph. Our application domain is really just the different entities and relation between them. So here in this example, we have the repository and user entities. And each of them has an edge connected to a primitive type that is probably stored in some kind of persistent data store. But also it has relations to each other via these repos and owner nodes. And actually, you can have multiple relations between those kind of types. For example, a user can have repositories he's looking at, repositories he owns, and also repositories that he's watching for, like, let's say, GitHub. And the repository can have users, which is the owner. It can also have users watching this repository. It can also have users that are starring the repository. And each of these connections are made by its own edge. So depicting our application as a graph allows your clients to send a query tree, which is a subset, really, of your whole application graph. That allows your GraphQL API server to traverse this query and call a resolver function for each field, which is depicted here by those smaller nodes. So every tree has a root by definition, and every query has an entry point. So in GraphQL, we define 3 possible entry points. The first would be query, which is the default entry point, which is just simple way of acquiring any part of your graph. A mutation, which is a semantic way to defining a query that should change the data store, like any kind of create, update, or delete actions. And the last one is subscription, which is a query that is evaluated every time an event is published. So let's take a look on the query syntax and try to break it down a little to understand what it holds in it. So each GraphQL query would have the optional operation type, which can be either query, mutation, or subscription. After that, we usually specify the query name, which is also optional, but the default will be an empty string. Next, we have a tree selection set, and this is the important part, really. On the first block, you would see, in this hierarchy, you would see that we go over our root selection set, or our root fields. In this example, I'm trying to get the me field, which is actually the user that is currently making the query. The next block would be the selection set of the user type. Me returns me a user type. Then I want to specify which kind of fields I really want from this user type. So in our case, I'm asking for ID, username, and channels. And lastly, the last block is a selection set of channels of the channel type. Channels fields actually return us a list of channels. So we actually can specify for a list which kind of fields we want for each item on this list. And for this example, of course, we require ID and title. After sending this query to my GraphQL API, I will get a response in the exact same shape as my selection set. So another thing, or one more feature for every field in our query is we can pass it arguments, and those arguments will be evaluated in our GraphQL API and will change the result returned to us. And this way, for this example, we are asking for, give me all of the messages that are in my application graph, and we give it a handle, like the argument for these messages. So I would get only the messages on the channel that has the handle 1. Yeah. Sorry, didn't click. So the same way as before, we would get the result exactly the same way we would get on we would specify the selection set. So a mutation. Let me just remind you before we take a look at the mutation that a mutation should behave exactly the same way as query does, but they are meant to be used to change data in your application. What does that mean? It means that it looks exactly the same apart from this first field, which actually dictates us that this is a mutation and not a query. So the most simple example for handling a mutation would be to just add a new object to a collection, such as sending a message to a channel, which I'm doing here. Yeah, sorry. Yeah. Then you would either get the affected channel after running this mutation. You would either get the affected channel back as a result of this mutation, or the message document that was created using this mutation. So let's start breaking it down. So we saw this mutation thing at the start. It's the operation type of this query. Next, we will again specify a selection set of the mutation root fields. So actually, we can specify various mutations in a single request. But up until now, I haven't seen a lot of people actually running it this way. So, let me know what you think about it. In this case, we want to send a new message. So what we are providing this new field as argument is the actual message object, and it contains text created, creation time, and channel ID. After that, we specify the selection set of the response. The response actually returns us a message type in this instance. So in addition to text and creation time steps, we also want the arrival time of the message and the ID of the document. Same as before, the response would be the exact same shape of the mutation selection set. Last feature I want to talk about in the query language is fragments. So sometimes our graph needs to have more abstract typing, such as interfaces or unions. And so in order to be able to query those types, we need a way of conditioning our selection set. The way to do that is called query fragments. So fragments can be inline or defined in another location and being spread on the query selection. Full definition fragment is also very useful for using query results. So you can put this fragment actually in any file you want in your project directory tree, and then import that into this query and reuse it over and over again. So the fragment syntax will begin with the fragment word. After that, we specify the fragment name. And after that, we will define our type condition. In this example, I want a fragment to be executed or to be queried whenever the type returned is a message. Inline fragments will start with the spread operator, the same you would see on the latest JavaScript syntax. And after that, we would just put the type condition. For this example, we just want all the messages on a channel. And if the message contains an image, we also want an image field, right? So our channel contains these abstract messages types. Some of them has other or additional fields. As you can see here, image message would be a message that is attached to an image URL. And so this query will resolve as in the same shape of our selection set, holding all of the messages fields with the extra image field for any sent images. So you can see it here, if I can get my mouse over there. Yeah, so at the bottom of this response, you can see that we only for the second message, we got another field called image with the image URL. So if this query language interests you and you want to learn more about it, there's actually a very thorough explanation on the query language with its different parts and additional directives. You should definitely read it. It was written by Sash Costobalo, and it's published on the Apollo blog post. And actually, I will publish later my slides, and you can just browse the links and look at any resource I show here. So all of the behavior I've explained is documented and published as a specification document, which is managed by Facebook. But it is developed by a highly active and strong community from all kind of frameworks and languages, because GraphQL is just a spec. It's not mandatory for JavaScript framework or whatever. So subscriptions, on the other hand, has been around for a while now. It's been around since, I think, start of last year. But it has never been part of the official GraphQL spec until recently. So it's not officially a spec. It's just an RFC. It was accepted this February. And it begins to specify how subscriptions work, really. The RFC describes our real-time solutions, other real-time solutions, and tries to define in high level the suggested solution, right? Mainly it will go over mainly it will go over through a life cycle of a subscription and the components needed to support it. So what are subscriptions and what is the suggested solution? Same as other real-time solutions, it pushes events from your backend to your clients. An important part of the solution is specifying that an event could be anything and its origin could be any component of your system, which is different from live query, for example, where only your data, only your live data will be pushed to the client. Also, as you've seen before, GraphQL lets the client define the shape of the response it requires. So for subscription, the same is true. And this actually the most important thing in this solution, that the client defines the shape of the data pushed to it. To get the hang of it, let's quickly go over a simple subscription lifecycle. And now the animations will start. So a client will send over a subscription query to the GraphQL API. And given that, the GraphQL API will store the query for later use in a subscription manager. This subscription manager is properly depicted here by this unsuspicious emoji lady. So at some other time, the other client will send a mutation with a follow action. And the GraphQL API will create a follow event and pass that to a subscription manager, which just realized what her real job is. So now the subscription manager quickly matches the event with the query it has previously got and sends back to the GraphQL API both the event and the query to be evaluated. And so thanks to the emoji lady, all of this will be possible. After evaluation, the GraphQL API pushes the query result to the subscriber client via some transport that allows pushing data. Actually, we've been testing out WebSockets, but it doesn't really have to be WebSockets. It can be whatever kind of transport that allows you to push data from the server side into the client. So the Apollo project has implemented a similar extension to GraphQL back in September. The extension is not in line entirely with this RFC, but it is definitely very close. So I would like to show you a small example of this implementation. The example we will see is taken from an app called GitHunt, which is essentially product hunt for GitHub repositories. This app is actually a demo for the features available in Apollo, and it allows you to rank GitHub repositories and comment on them. Now, for each repo, there is a comments page, and we would like to get the most new comments as soon as they are added. So in order to accomplish that, after querying our initial set of comments, we will subscribe to any more comments added to this repository. The first thing we need is to define the subscription in our GraphQL schema. This is done by adding a new type called subscription. Under this type, we specify our event topic. In this example, we want to be able to subscribe to added comments on a certain repo. And so we set a subscription to return comment type for each related event. Next thing, we need to add a subscription manager that we've seen with the emoji lady. So we give it our schema that we've just created, a pub sub engine, which is shipped actually with the same package, and it's actually a simple event emitter, and a map object between subscription and trigger topics. On our example, we use only one trigger topic, same as our subscription, but we pass a filter to it that allows us to only evaluate comment-added events when it's related to our subscription repo. So a trigger topic is really another way of looking on the topic of a subscription. And it basically translates to any kind of topic that could create your subscription to be updated. So each time a comment will be submitted, we will use our pub/sub object in order to publish the comment on the comment-added topic. So we need actually that pub/sub object in order to publish our events. And one last thing we need is to add to our server is a transport that will allow us to push the query result to the clients. As I've said before, Apollo has created such transport using WebSockets. And through these WebSockets, we actually get the subscription messages as well. So we have to pass it the subscription manager as well. The transport will listen on each subscribe message we will send, and we'll pass it to the subscription manager, with a callback function that will just push the query result to the client on each event. So this was our subscription server fully configured, actually. Now let's take a look on our client. So we first defined a subscription query. It looks exactly as a regular query looks, but it will be executed only when an event is fired. So the fields we've specified here are actually just exact fields that we need in order to render this comment view on our comments page. Next, let's define our WebSocket client. It's a simple initialization process, and once it's done, we basically can just call subscribe using that WebSocket client on the block in the middle over there. For our example, actually, we will use Apollo client. And so we need to extend our current Apollo network interface with the WebSocket network interface. And this allows Apollo to execute subscribe and unsubscribe methods on this transport. So next, we initialize the Apollo client itself. And using either Angular or React, I'm not going to get into comparison wars or something. We just provide the Apollo client to our components. So the middle block would be for React, and the later one would be for the Angular dependency injection provider. And it's just a simple object that you can depend on whatever UI you have. So lastly, we want our comments page to subscribe to new comments when it loads. So in order to do that, we will call our client subscribe method with the subscription query string and the variables object holding the repo full name. This method will return us an ECMAScript observable, actually. Now, what we want to do is to update our store whenever a comment is being pushed to the client. In order to do that, we will subscribe to that observable, and on each next value call, we will call Apollo's write query method with the original comments query and the new added comment. So actually, Apollo does allow us to do these kind of operations much more easily, but I didn't want to get into those kind of APIs because they are very view-specific or view language-specific. Okay, so last code slide, I promise. After updating the store, our chosen UI framework will re-render the comments list with the new comment. And that's mostly it. We've successfully configured a simple subscription setup, and we now get events being pushed to our client just as the client requires it. So up until now, we've talked about GraphQL-only systems, meaning each of our events were actually mutation results being pushed to other clients. But we can also add GraphQL subscriptions to other non-GraphQL systems or other non-GraphQL data sources. I lied, actually. Like, this is the last. In order to allow that, we should take a look back on our PubSub object. Given we have other way of notifying our server of any events that being published, we can use this PubSub object to publish this into any GraphQL client. So the way it will work is our client will send a subscription query to our unified GraphQL API server. The API server will then subscribe on its own to other IoT bridge or PubSub broker or whatever kind of reactive or event-emitting data source you have. Then once an event is fired through any of these sources, the GraphQL API server will get notified, run the client's query, or run the client's subscription query, and push that results to the client via the same transport we mentioned before. Other cool thing that we can do with GraphQL subscription is enriching events, which actually what it means is that every time an event will be published, we can get additional related data that the client needs in order to avoid underfetching. So when a client app sends and we follow mutation, it will get back right away its mutation response with whatever it needs to render the view, right? So, but looking again at the mutation, the client hasn't really sent much data for the event to contain. Basically, it only sent the user handle to follow, and because the user is logged in, there is also the user ID or the user object on the GraphQL context, but that's it basically. And if we look at our notification view, we can actually see that we need the full name of the user and the profile image of the user in order to properly render this new notification. So when we send over our subscription document, it will contain these two fields on the selection set, name and image URL. So then after the mutation arrives at the GraphQL server, it will then start reversing the subscription query, going only from the follower added event, which is the box above, and this has only the follower user ID and the target user handle, and will start querying your data store or whatever you have that holds that information, and build the response you need for your client. So the last thing I would like to talk about is how to get this subscription setup to be more production ready. If you remember from before, I've said that our subscription query will run for each event fired, and GraphQL execute will call a resolver function on each field we see on this query actually. Not only that, we also can see on this particular query that we want to get the login name and the HTML URL from a user object, the user that actually wrote this comment. So this means that every event evaluation will quickly become a pretty heavy operation. And for us to be able to support growing user base and events, we need to scale horizontally in some way. And our query execution on our query execution part of the application. So in order to scale, we need a way of notifying all of our GraphQL servers when an event has been triggered. So in order to do that, we can actually just implement the PubSub interface, PubSub engine interface with something other than an event emitter that I've shown you before, and pass that to the subscription manager instead. So let's take a look at how it will work. A client will send a subscription query to server number 1. This subscription query will then be sent to some kind of PubSub broker. In our example, we use Redis. So the topic will be made out of data relevant for this subscription. At a later time, when user sends follow mutation to server number 3, it will then send a publish command to our Redis server. The publish command will be composed out of our previous topic, and it will include the following user ID on the payload of the event. Our Redis server will then publish the event to server number 1, which has previously subscribed to this actually the same topic. So that server will now execute the subscription query the same way as before, and then it will be pushed to our client in the same manner. So this is actually quite a common way of scaling, and so I've wrote 2 PubSub adapter packages using Redis and MQTT protocol. So you can go over and use it right now and just roll your GraphQL application to production. And actually in Meteor, we use, if you know, Meteor has a platform for hosting called Galaxy, and events over there are being pushed with GraphQL subscriptions using MQTT. So using those packages is really, really easy, as I've shown you, just creating this Redis PubSub and giving that to the subscription manager instead of the other PubSub object. So if you want to learn more on this topic, I wrote a blog post on it with examples, advanced usage, and benchmarks. You can go ahead and read it. And that's basically it. If you enjoyed this talk and you want to know more, I recommend you to follow me on GitHub or Twitter, where I post most of my GraphQL-related activity. Also, don't hesitate to call me by email, which is published on my GitHub page. Last thing, really. If you come around to Tel Aviv or Israel, just like ping us and come visit us at the office. We really like to hear about the use cases, and we really want to get to know people from the community, as I've said before. So just come over, ping us, and whatever. That's it. Thanks for listening. Thank you.